Okay, so the solution for this one, we can define two variables, so a and b. A will be the smallest value of the sequence, b will be always the second smallest value, right? So I have a few examples here. I will show you how it works. So first iteration, I'll check the one, and first I'll set the a and b to be the maximum possible integer, right? So it's basically positive infinity. So I check, okay, is 1 less than positive infinity? Yes, it is. So then I set a equals 1. So this is the smallest value I have so far. So then I go to the next iteration, and I ask, okay, is this one less than a? No, it's not. So it's bigger. So if it's bigger, then this must be the second smallest value I found so far. And then I keep looking at the other ones, right? I go to the next iteration, and okay, is this number less than b? No, it's not. It's bigger. So at this point I have a and b, and I have a third value. If I have a third value, I now return true, because I did find an increasing subsequence of 3, right? So yeah, so let's check this next example here. So I check, okay, is 4 less than infinity? Yes, it is. So I set a to be 4. Then I look at the next one and I say, okay, is this one less than a? Yes, it is. So I need to update a to be 3, because it's always the smallest I found so far, right? So at first the smallest I found so far is 4, then now it's 3, and then the smallest so far, yeah, and so on, right? I move on to the next iteration, and it's 2 less than 3. Yes, it is. I keep updating a until I go to the last one. So this is the descending array, right? So in this case, I don't find b, and I don't find the third one. So I do return false. So yeah, so this third case here, I start same thing. So is 1 less than infinity? Yes, it is. So I define 1. I look at the second one. Okay, is it less than a? No, it's not. So it's bigger. So I need to define b, right? So then I move on to the next one. Okay, so the first question is always, is it less than a, right? So is it less than a? Yes, it is. So I need to update a to be here, and then I look at the next one, because I always, as I move on these positions, I always need to know which is the smallest value possible and which is the second smallest value possible, right? That's the reason. So when I reach this last position here, I ask myself, okay, is this number less than a? No, it's not. It's bigger. Is this number less than b? No, it's not. It's bigger. So if it's bigger than b, then for sure there existed before. So the a, even though I updated the a here, the a, when I define b, I for sure had an a that was less than b, right? Because I need to define a and then b in this order, right? So I for sure, if this third number is bigger than direct x, there exists an increase in subsequence. So in this case, I return true. And yeah, that's pretty much it for the algorithm. So basically, we define a, we define b if it's bigger, and then we look for a third number. If we do find, then we return. If we don't find, then return false, right? So yeah, that's the algo. Okay, so now let's start coding the solution. So the first thing you need to do is define a and b. So let a be number max safe integer, and b also max safe integer. So let's make a loop here. Yeah, loop. So the first thing you do in the loop is you ask, okay, is the number less than a, less or equal, right? Then a, if it is, then you update a to be the number. If not, then we check for b, is the number less or equal than b. If it is, then you just do you set b, right? Nums I. If you define a and define b, and you find a bigger value, which is not less than a nor less than b, then you return true. And if you did not hit return true inside the loop, you just return false. So yeah, that should be it. I'll run it. Yeah, I got accepted here, and now let's submit. Wait a little bit, and yeah, we got accepted.